This is the Precalculus third 9 weeks test preview. Probably early next week we're going to be having this test in Precalculus. This is going to be a quick preview for that test. Trigonometry, law of sines, law of cosines. I'll go over these problems pretty quickly. I have 13 of them in this preview. For the triangle ABC shown below, what is the length of the unknown side B to the nearest tenth of a centimeter? And what you're looking for is if you have a known side opposite a known angle, you have a situation where you can use law of sines. So this ratio, this governing ratio of 30 over not 70 degrees, but sine of 70-degree angle is equal to our unknown side B, this little b here, over the sine of the angle opposite B, which is 37 degrees. So cross multiplying, B is going to be equal to 30 sine 37 degrees over sine of 70 degrees. So B is approximately equal to, I'm going to go to our calculator. And the first thing I notice, that you should notice too, is my calculator is in radians. And given that our angles are in degrees, I'm going to change the setting here to degrees. And I get out of here, and then I go and re-examine our equation. 30 sine 37 degrees over sine 70 degrees. So 30 sine 37 degrees over sine 70 degrees. And for that, 19.2. So about 19.2. And it's going to be approximately, there we are, answer choice C. Next. For the information given in the drawing below, what is the measure of the angle P to the nearest tenth of a degree? Here we have angle P unknown, but we have a known side opposite a known angle. So what we have is sine of angle P, which we do not know yet, over side P, which is 9 meters, is equal to sine 114 degrees over 24 meters. And so P is, I'm just going to write that sine P is going to be equal to 9 times sine 114 degrees over 24. And so P itself is going to be equal to the inverse sine of this expression, 9 sine 114 degrees over 24. And so let's go ahead and go to our calculator. Okay, we put inverse sine of 9 sine 114 degrees. Let me get up here, make sure I got a closing parentheses, over 24. And let's see what we get here. 20.03 degrees. Which is closest to answer choice D? Next. John and Bob hike in different directions according to the drawing shown. If Bob hiked 5 miles and John hiked 4 miles separated by an angle of 100 degrees, how far apart are they to the nearest tenth of a mile? We have a unknown side opposite a known angle, and our other two legs of this angle are known. So this can be a law of cosines application. So that's going to be c squared equals a squared plus b squared. So I'm going to put 4 squared plus 5 squared plus 2 times 4 times 5 cosine 100 degrees. And if our angle is 90 degrees, this last term doesn't matter. And I made a little mistake there, didn't I? That's supposed to be minus. Check your formula charts. So C is going to be equal to square root of all this business here. Okay, so we'll put 4 squared plus 5 squared minus 2 times 4 times 5 times cosine 100 degrees. And we will have our answer here. So go to calculator, get the square root. Now, a very common mistake here is to forget to take the square root. But an antidote to that is if you're thinking your way through these problems as you work them out, you should realize instantly if you forget the square root when you see that you get a totally unrealistically large answer. Times cosine 100 degrees. And we should have it all here. And we get 6.92 miles. And so it's going to be 6.92 miles, which is closest to answer choice D. Next, a ship moving towards an island at a point F. So you got this ship at point F, Steve between point E and the lighthouse at point D, an angle measuring 67 degrees. So 67 degrees is the angle between looking out at the island on the right and the lighthouse on the left. And we know that that distance between the island and the lighthouse is 20 miles. So we have a known side opposite a known angle. There it is. And we want to know side D. So side D to sine of the side opposite D, which is 36 degrees, is equal to our known side 20 miles over sine of 67 degrees. So therefore D is going to be equal to 20 sine 36 degrees over sine 67 degrees. So D, let's get our calculator here. (20 sine 36 degrees over sine 67 degrees). So there we have 12.77 miles. Again, we have answer choice D. Answer choice D seems to be a popular one these days. Okay, now a vector problem. Coordinates of point A are 1, 4, and the coordinates of point B are 3, -4. So what is vector A, B in component form? Well, B is what's called our head. are the finishing point, and A is going to be our tip or tail. So to find a vector, we're going to use head minus tail. And for that case, our B, and B is going to be 3, comma, negative 4. And we have A is going to be 1, comma, 4. And we subtract, we have a vector AB is equal to, put in the brackets there, 3 minus 1 is 2, and negative 4 minus 4 is negative 8. So our correct answer is answer choice B. Next, vector B is a vector 2, comma 3, and vector W is negative 4, comma 5. If vector P equals 3B minus 2W, what is vector P in component form? Well, we could say 3B, because we want to have 3B. So 3B equals 3 times 2, comma 3, and that's going to be equal to 6, comma 9. And then 2W is equal to 2 times negative 4, comma 5, which is equal to negative 8, comma 2 times 5 is 10. So what we want is 3B minus 2W, and you can set these up vertically like I'm doing here, or horizontally if you can keep it straight that way. So I have 3B is 6, comma 9, and below it 2W is negative 8, comma 10, and just subtract, so we have vector P, which is a subtraction of these, is going to be 6 minus negative 8, which is 14, and 9 minus 10, which is negative 1. So that gives us answer choice A. Next, Rodney walks to the library after school every day. When Rodney leaves school, he walks 10 blocks due west, and then 9 blocks due north. What is the magnitude and direction of the resultant vector? So I'm going to just sketch a little vector of Rodney's walk here. So west is over this direction, and north is up here. And Rodney goes 12 blocks due west. So here he's walking 12 west, right here. So here's 12. And then he's coming up here and going 9 north. So this is 9. And we want to have the total distance here. Right, what is that distance here? And the direction. Okay, so we want to find this direction here. And all these are west, something north. So our magnitude is going to be square root of 12 squared plus 9 squared, and we work this out, we're going to get 15. So 15 is our distance. Now the other answers given, 21, would be like a total distance traveled, and not, and so anyway, and what is our angle going to be? Well, theta is going to be equal to our inverse tangent of opposite over adjacent. So theta is equal to inverse tangent of opposite divided by adjacent. I'm getting 36.9 degrees. And that looks like it's going to be answer choice D. Okay, next. What is the reference angle for an angle that measures negative 225 degrees? You can't have a negative reference angle, nor can you have one greater than 90 degrees. So here we are. It's going to be between one of those two. So if you go negative 225 degrees, it's going to be like this. Negative 90, negative 180, negative 225 degrees. So it's going to be right here. So negative 225 degrees. And what you can do is this angle here is going to be positive 135 degrees. And so either way you look at it, if you take 225 degrees minus 180, you're going to get 45 degrees. 135 degrees plus what equals 180? Because we're at 180 over here. So yeah, our answer is going to be, our reference angle is going to be 45 degrees. Okay, next. We have this thing right here. We want to find the coordinates of P prime. Well, to do this, we have x equals r cosine theta. One of the first things we talked about this semester, and y is equal to r sine theta. And here we have in cosine of 330 degrees is going to be equal to square root of 3 over 2. And sine of 330 degrees is going to be equal to negative 1/2. And so, and you can just put these in the calculator, you'll be okay. And r is equal to our diameter of 20 divided by 2, or 10. So our x-coordinate is going to be 10 cosine 330 degrees, which equals 10 times square root of 3 over 2. Well, that's going to be equal to 5 times square root of 3, our x-coordinate. So it looks like it's probably going to be this one here. And then our y value is going to be 10 sine 330 degrees, which equals 10 times negative 1/2, which equals negative 5. So yes, B is our correct answer. You can just see the signs of the, you need to have a positive, x value positive, y value negative, which automatically disqualifies answer choices A and C. Okay, two forces act upon objects as shown. You have apparently this dog is being pulled by different leashes. And what's the magnitude of the resultant force? Well, our magnitude, we have these two vectors here, the 20-pound vector and the 16-pound vector. So one vector, I'm going to give myself a lot of room. I guess that'll be enough room. So we have 20 cosine 20 degrees plus 16 cosine negative 27 degrees And so that's going to be our x component of force. And then for y, we have 20 sine 20 degrees plus 16 sine negative 27 degrees. So that's what we're going to look like. So we can just go to our calculator and put them in, see what we get. So we get 20 cosine 20 make sure I get the values right here. $20 degrees plus 16 cosine negative 27 degrees so we get this value here, 33.05 approximately, and then we put in 20 sine 20 degrees plus 16 sine negative 27 degrees. We get this value here, negative 0.42. So we can just find the magnitude like this. We can go to second parentheses. I'm going to put 33.05 squared plus, parentheses. I'm going to put the last number calculated here, which is going to be second answer for A and S, close parentheses, square that, and we get 33.05. So I'm just going to say magnitude equals 33.05 pounds. Where's that going to be? That's the closest answer, choice A. Next, vector v in component form is negative 6 comma 9. What is the magnitude vector v to the nearest tenth? Well, magnitude is going to be equal to negative 6 here squared plus 9 squared. So that's going to be 36 plus 81. So that's going to be square root of 36, 81. Let's go here. Square root of 36 plus 81. 10.8. Says to the nearest tenth. That's choice D. Next, to find the measure of angle B to the nearest degree, mark your answer in the grid provided. And here we have angle B down here. Well, this is going to be the law of cosines. I'm going to show you how this works out. If we put 17 squared equals 10 squared plus 11 squared minus 2 times 11 times 10 times cosine of angle B. And so when we simplify everything here, I'm just going to write up the formula here. Angle B is going to be equal to inverse cosine of 17 squared minus 10 squared minus 11 squared over negative 2 times 10 times 11. And that's going to be it. So let's go ahead and work that out. in our calculator. Inverse cosine of 17 squared minus 10 squared minus 11 squared over negative 2 times 10 times 11, and we close this. We are in degrees. We should be good. 108 degrees. And that's answer choice C. Okay, what's the area of the triangle shown the nearest tenth? Now, if you look at this prior problem, it's the same triangle, but we're being asked a different question about it. One thing we have here, as far as area, we have three sides, something called Heron's formula, which is going to be area is going to be equal to the square root of S times S minus A times quantity S minus B times quantity S minus C. And one thing we did in our class is we did a little program to do this, but S is semi-perimeter, which is going to be these lengths here, 17 plus 11 plus 10 divided by 2. And so what we're going to have is 38 divided by 2, which equals 19. So our area is going to be equal to square root of 19 times 19 minus A, which is 17. Well, the letters do not matter. 19 minus 11 and 19 minus 10. So A, okay, let's go to our calculator. We have 19 times 19 minus 17, 19 minus 11, and 19 minus 10, and we should have them all right here. 52.3. And that would be to the nearest tenth, okay? That'd be answer choice A. So 13 problems should be helpful. I think your test next week's going to have like 22 problems. Shouldn't be that hard at all. Good luck. And as always, thanks for viewing.